There we go. So what we're going to be doing is we're doing the car problem, and we're looking at a car that's rolling down a hill. I just had to redo this thing because my first one was kind of sloppy and I don't want to have that. We'll have some just silly mistakes. So we're given there's an accel at 4 meters per second squared. The delta x is 50 meters. From there to there is 50 meters. The cliff is 30 meters up. So find the time and delta x, this delta x more specifically. Yeah, and for the car in the air, so when it's rolling down here. So what we're going to do is we're just going to set up a quick little table. And we know the VI is 0. VF is what we're looking for because VF is going to give us this. We know delta x equal to 50, and then acceleration is equal to plus 4 meters per second squared. So what we can do is we can get VF squared is equal to VI squared plus, what is it, 2A delta x, yeah. And when we plug that in, we're going to get VF squared is equal to 0 plus 2 times 8, 2 times 4, times 50. And that's going to get VF squared is equal to 400 square root both sides. We're going to get VF is equal to 20 meters per second. So that's going to be our V naught. So we're just going to write 20 there. And we're going to clear this out. So let's just switch this off. Bam. Wipe that. There we go. And we're just cruising right along. Alright, so next, what we have to do is we use the sine of each angle. So now we're going to do VF. So we're going to draw in our vector arrows. We're going to label our x components along with our y components. X, y. So Vx is equal to 24. So we're going to be looking at cosine. Cos 24 times 20. And that's going to give us meters per second. VIY is going to be the opposite. It's just going to be sine 24 times 20. The acceleration is equal to negative 9.8 meters per second squared. Delta y is equal to minus 30 meters. We're looking for t, we don't know that. Put a big old question mark. And we're looking for delta x, so put a big old question mark. And we also do not know time. So the first thing we're going to have to do is solve for time. And for this equation we're going to be using, we have 3 out of 5. So delta y is equal to VIT plus 1 over 2 a, that's not 2, 1 over 2 a t squared. So negative 30 is equal to v, so VIY, in this case since we're using it from the y category. So it's going to be sine of 24 times 20. So we're going to get 8.13. And we're going to get negative 8.13 meters per negative 8.13 t plus negative 4.9 t squared. So we can just move this along here, and now we have a quadratic equation. To solve this, we're just going to plug it into the quadratic formula. So we're going to get negative b, so 8.13 plus or minus square root of 8.13 squared. Negative will cancel out, so I'm just not even going to include it. And then minus 4. And then AC. So we're going to get negative 4.9 times 30. And we're going to be putting this over a negative 9.8. So the only way we're going to get a negative is if we subtract it. So don't even bother adding it. Because if we add it, that's just going to give us a negative time. And time cannot be negative. So, let me just put this all over as a fraction. 8.13 plus square root 0.13 squared plus minus, actually we can just do plus because the negatives cancel each other out. 4.9 x 30 all over negative 9.8. And we're going to subtract in this case. I'm going to get time is equal to 1.78 seconds. Now that we know the time, we just simply plug in and solve for delta x. Delta x, which is d, is equal to r times t. So we're going to get vx times t. Now we solve delta x is equal to cos. So cos 24 times 20. And then we're going to multiply that times 1.78. And we're going to get delta x is equal to 32.5 meters. So we have that and we have that. So thank you for watching. Have a great rest of your day, and I hope that helped.